This is Mr. Collier. We're going to talk about vertical and horizontal lines today, the general form of the equation of a line, and some other things as well. So if we look at vertical and horizontal lines, vertical lines always have an equation of x equals a. That's because on a vertical line, like say this vertical line, the x value is always 3. Like this point here is 3, 0. This point here is 3, 1. This point way up here is 3, 5. So you see the x value is always 3. That's why the name of this equation is x equals 3. And that's always going to be the case for vertical lines. You have x equals some constant number. And this equation over here is going to be x equals negative 4 because the x value is always negative 4 along this line. And if we look at the vertical lines here, we always have y equals some constant. So down here we have y equals negative 1 on every point on the line. So that's y equals negative 1 is the equation of the line. And this one here is y equals 2 is the equation of that horizontal line. Okay, so let's look at a couple of examples. I'll write down the equation of each line in the diagram. So A goes through y equals 5, so the equation of that line is y equals 5. And for B, we have a vertical line going through negative 2 there, so it's x equals negative 2. Now we have to draw some horizontal and vertical lines. So x equals 1 is going to be a vertical line through 1. X equals 1 is going to go down through like that. So that is the equation. Let's label it x equals 1. The next equation is going to be y equals negative 3. So we go down to where y equals negative 3. It's going to be along here, a horizontal line. And the last one here is y equals 0. So y equals 0 right here. That's actually the equation of the x-axis. Is y equals 0. Okay, and then for example number 3 here, write down the equation of a line passing through 3, negative 1, and 3, 3. Well, notice the x value is the same in both cases, so we don't need to find the slope. If the x value is always going to be 3, then the equation is x equals 3. And in the second example, the y value seems to always be 4. So we can say that the equation of the line is y equals 4. Okay, let's look at a few other examples. Write down the gradient and y-intercept of this line. Write down the equation of the line, and you must know at least one point on the line to be able to find the slope. Okay, so we're going to find the gradient and y-intercept of this, and this is in standard form or general form or something right now. We're going to change that to gradient-intercept form or slope-intercept form. So 2y plus 3x minus 2 equals 0. And we're going to solve for y, so let's bring everything else to the other side of the equation. And their signs change. And then here we have to divide by 2. So we get y equals negative 3 out of 2x plus 1 when we divide. And it says write down the gradient and the y-intercept. So the gradient is negative 3 out of 2. The y-intercept B, or maybe even C depending on what you use. The y-intercept is 1. Okay, now write an equation gradient-intercept form of the lines that pass through the points and have the slopes given below. So we're given a slope, we don't know the y-intercept, so we can write y equals mx plus b. And we know the gradient is 12. Don't know the y-intercept, but we do know a point. So you can take this point, the x and y value of that point, and substitute it into the equation. We have negative 8 equals 12 times, now I've got them backwards, don't make that mistake. The y value is 2. So be careful there. So let me erase that properly here with a smaller eraser. Okay. So we had the y value is 2. 2 equals 12 times negative 8 plus b. 2 equals negative 96 plus b, and b equals 2 plus 96, which equals 98. So the equation of this line is y equals 12x plus 98. The second equation, we're just given a pair of points, so we can find our slope first by doing y2 minus y1 out of x2 minus x1. Right, so I'm going to do this y minus this y over here, and then you have to do the same thing with the x's, go in the same direction. So the gradient is equal to, we do negative 2, now be very careful, this is where people go wrong, is negative 2 minus a negative 1. So it's like a double minus there, minus negative 1 out of negative 1 minus 5, which equals, well, that's negative 2 plus 1 on the top, and then we have negative 6 down here. So this gives me negative 1 out of negative 6, which equals 1/6. Okay, so that's the slope. Or, yeah, that's the slope. So we can write our equation as y equals 1/6 x plus b, because we don't know the y-intercept yet. And we can take one of these points now, either one, up to you, and substitute it into the equation and find the y-intercept b. So we put in negative 2, which equals 1/6 times negative 1 plus b. So negative 2 equals negative 1/6 plus b. And we can add 1/6 to both sides. Yeah, well, I could also multiply by 6. Let me do that. I like that better. So if I multiply by 6, I'll get rid of that fraction. So I'll have negative 12 equals negative 1 plus 6b. We'll add 1 to both sides here. We'll get negative 11 equals 6b, and b equals, if I divide by 6, negative 11 out of 6. So the equation is y equals 1/6 x. That's positive there, right? Okay, so that's minus 11 out of 6. Okay, next examples. Now we're going to use general form. So general form looks like this, or actually I think general form technically looks like ax plus by equals c. We'll put the constant over here, but it really doesn't matter too much. So we're going to put it in this form. We have the y-intercept and we have a point. So we can write y equals mx plus 1 because we have the y-intercept, and then we could find the slope by simply substituting this value into the equation. 6 equals m times negative 4 plus 1. 6 equals negative 4m plus 1. And we're going to subtract 1 from both sides. We get 5 equals negative 4m. Divide by negative 4. We get m equals negative 5/4. So the equation is y equals negative 5/4 x plus 1. We want to put it in general form. So first thing you do, you want in general form, you want actually a, b, and c should be integers. So we don't want fractions, so we're going to multiply everything by 4 first. So we're going to have 4y equals negative 5x plus 4. And we need the x's and y's on one side and a number on the other side. So we're going to add 5x to both sides. So we get 5x plus 4y equals 4. And that's the general form of the equation. Okay, in the next example, we can do something similar. We can get the slope first by doing 16 minus 15 and 3 minus 2. Sorry, 16 minus 15. So that actually equals 1 out of 1, which is 1. So the slope is 1. We don't know the y-intercept yet, so let's do y equals mx plus b. Put in this, put in one of these points, either one. So actually we have 1 equals slope times, actually slope is 1, sorry. Let me just do some erasing here. Okay, the slope is actually 1. We figured that out earlier. So we're going to have 1 times the x value here, which is, no, that's 15 and 2, so that should be 15 for the y value, 2 for the x value, plus b. and then we'll have 15 equals 2 plus b, so therefore b equals 15 minus 2 is 13. So we have the slope, we have the y-intercept. We can write the equation now as y equals 1 times x plus 13. And to write that in general form, well, let's subtract x from both sides. We'll get y minus x equals b. Now technically I don't think you really have to do this, but we want x before y. So if you do negative x, so that's 13 right there, isn't it? It looks kind of like a b. Just a second. Okay, so if you want to do that, you can rearrange x and y there. And if you want that to be positive to make it look neater, we can multiply everything by negative 1. And we'll get x minus y equals negative 13 is our general form of the equation. Okay, example 4. Rearrange the following line in this form where a, b, and d are integers. So it's kind of like general form with their constant over on this side of the equation. We're going to rewrite this. So like I said before, we don't want fractions, so let's get rid of that right away. Let's multiply by 3. We get 3y equals negative 6x plus 1. And if we add 6x to both sides, we get 6x plus 3y equals 1. And actually we want it in this form, so let's subtract 1 from both sides of the equation. And there we go. There's our answer. Okay, next we are finding the equation in gradient-intercept form. So we need the gradient, we need the y-intercept. There's the y-intercept, is 2. The gradient we can use an equation, but we can just see here that to get from one point to another, you go up to left 3. So the slope, or the gradient, is 2 out of negative 3, which equals negative 2/3. So your equation is negative 2/3 x plus 2. That's all there is to that one. Does a point lie on a line? So how do you know if a point lies on a line? Well, if you have a point and you have an x and y value of a point, then if you put the x and y value into the equation, it should satisfy the equation, which means it should make the equation true. So we just plug in the values of y and x. I'm going to put a question mark there because we're testing if this is going to be equal. So we have negative 4 equals 4 plus 13. That is certainly not true. So therefore or I could say 2 comma negative 4 is not on the line. Okay, in the next example, you're given a point, but we don't know the x-coordinate. It lies on this line. Find the value of a. So we know if it lies on a line, then if we substitute this point into this equation, it should be true and it should be equal. So we can solve that way. So we can say 5 equals half times the x value, which is a in this case, minus 4. Well, I'm going to get 5 equals half a. Actually, I'm going to get rid of the fractions right away by multiplying by 2. We get 10 equals a minus 8. And add 8 to both sides. We're going to get 18 equals a. And there's your a value.